For a motion, we know average velocity is measured by total displacement by total time. But what about the velocity at different instant of time? It may be 0, positive, negative, more or less than average velocity. Do you know how to measure this instantaneous velocity or speed in different scenarios using graphical or differential methods? Stay with me and learn the concepts of instantaneous velocity and speed in most easy and interactive way. Speedometer. A speedometer shows you the instantaneous speed, and if you add direction to that, it is instantaneous velocity. Instantaneous speed is always equal to magnitude of instantaneous velocity. So in case of instantaneous velocity or speed, we can use this word interchangeably for magnitude purpose. So if we talk about time, we generally talk about instant of time as 3 p.m. or 4 p.m. Or we talk about the duration of time like 2 hours, 3 hours or 4 hours. We saw use of time duration in measuring average speed and velocity in our previous session on average speed and velocity. But whenever we talk about like 4 p.m., we are talking about the instant of time. Or in car motion, if we ask speed of car when it passed through a point, we are talking about the moment or instant of time when car passed through that point. So if we take a snapshot of a speed, then the speed of car at that instant is its instantaneous speed or velocity of car. Now question is how we can find the instantaneous velocity. To find the instantaneous velocity for a travel, we should have information about that motion. The information of motion can be in form of displacement time graph, or it may be in form of displacement function with respect to time. Let's take an example to understand what is instantaneous speed or velocity. Here there is a car motion is given by a relation s equal to tan t square, where s is the displacement and t is time. Now if I put the value for t as a 1 hour, 2 hour, I will get the position of car at that instant of time. So here I have put that value for t is equal to 1, the displacement is 10 km. For time 2 hours, displacement is 40 km and so on. Now if I take these values and draw a displacement time graph, I will get something like this. So this is a displacement time graph, or you can say position time graph. So now if I want to know the average velocity between point A and point B, here the point A having coordinate 110 means 1 hour and 10 displacement, 10 km. Here point B is 5 hours from the start of its motion, and 250 is the displacement or position with reference to point O. So we know the average speed or velocity between point A and point B can be found out by rise upon run. So here the average velocity is rise is 250 minus 10 and the run is 5 hours minus 1 hour. So this is 4. So this is coming out 60 km per hour. So we know the average speed between point A and B is 60 km per hour. What does that mean? It means if car travel with a constant speed of 60 km per hour, it will take 4 hours to cover 240 km. Although the speed of the car or velocity at different time, like for example at the time of 2 hours, it's a 40 km per hour. At the time of 4 hours, it's 80 km per hour. So this instantaneous speed was different than whatever average speed we are getting between point A and B. Now to find the instantaneous speed like this 40 km or 80 km per hour, we have to keep decreasing this duration. As of now, in this case, we use the duration 4 hours. If we keep on reducing this duration to an extent that the time duration is nearly 0, then the whatever speed we get, that will be speed of the car at that moment. So the average speed become your instantaneous speed in case when this del S del t and del t tends to 0. So what we are doing is the duration we keep on reducing to such a small time period which is nearly 0, then whatever speed is coming by this formula is your instantaneous speed. Now this particular relation del S by del t when del t tends to 0 is derivative of S with respect to t. So we can write down V instantaneous speed is ds by dt, the derivative of displacement with respect to time. Now on graph, this ds by dt is nothing but the slope of the curve on st graph at any instant of time. For example, if I need to know the instantaneous speed at 2 hours from the start of its motion. So what I am doing, I will draw a tangent line at t is equal to 2 hours to that car motion curve, and this tangent line is jk. Now the slope of this line will give me the instantaneous speed at 2 hours. If you see the coordinates here, the slope here v instant at 2 hours is nothing but the 60 minus 20, which is a rise, divided by the time duration 2.5 minus 1.5, and this becomes 40 kilometers per hour, and that is what this instantaneous speed. Now similarly, if I want to know the instantaneous speed at t is equal to 4 hours, I will draw a tangent at t is equal to 4 on that curve, and I will take the slope of that line similar to whatever we done here. So here the slope of this tangent line is 200 minus 100 divided by 4.5 minus 3.25. And this comes out to be 80 km per hour. And that is instantaneous speed at t is equal to 4 hours. So this is a way to find out the instantaneous velocity using the ST graph. Now the same thing we can find out by using the calculus, the derivative, whatever we talked about here. I will take s here, which is 10t square. Okay, and if I derive this s with respect to t, I get instantaneous velocity, which is ds by dt, and this has become 20t. Now if I put the value of time, the displacement at hour 1 will be 10 km. The velocity at time t is equal to 1 will be 20 km per hour. At instant of time 2 hours, if I put the value of t as 2 hours, so this will be 40 kilometers, the displacement or position, and here it's v1, and v2 at 2 hours will be, if I put t is equal to 2, here 40 kilometer per hour. Similarly, as 4 at instant of 4 hours, and similarly as 6. So this is a simple way, by using the derivatives, you can find out the instantaneous velocity or displacement. To understand this more, let's take another example. So displacement is given by s equal to t square minus 6t. So if I need to find out the velocity will be ds by dt, and that will be equal to 2t minus 6, and acceleration will be dv by dt, and that will be equal to 2. So here you can have different type of questions. As an example, here for example, question may be like, find the period in which you have negative velocity, means velocity in negative direction. So find period where you have negative velocity. Another type of question can be, at what time the velocity of the object is 0. And the third type of question may be the motion after v is equal to 0, means what type of motion it is. Is it traveling in positive x direction, or velocity is positive, or it's traveling in negative x direction, or velocity is negative. So motion after v equal to 0. Remember, if velocity is positive, it means object is traveling in positive direction, and if v is negative, it means object is moving in negative direction, and that is irrespective of position of object. The object may have the negative displacement, or it may be having position in negative x direction, but the velocity can be positive. So the displacement or position can be positive or negative. The direction of velocity doesn't depend on that. Direction of velocity depends on the sign of velocity. Okay. So for the first part of this question, like the period where the velocity is negative, it means we have to put v equal to 2t minus 6, and its value should be less than 0. It means 2t minus 6 less than 0, or you can say t is less than 3 hours. It means for the first 3 hours of motion, the object is moving in negative direction. Okay. Now let's move to the question number 2. At what time my velocity will be 0? To find out that, we have to use this equation and put this equal to 0. So v equal to 2t minus 6 equal to 0. This gives you t is equal to 3 hours. That means the car speed will be 0 at the instant when time is equal to 3 hours. Now for question number 3, motion after v equal to 0 means motion after 3 hours. Now to better understand the complete motion of this car, let's take this car motion and depict on reference line. So here is the origin from where the car is started, and this is my negative direction or negative x direction. This is my positive x direction. Now let's take t is equal to 1 hour. At this time, what is my displacement? S equal to t square minus 6t, t square minus 6t, and this will give you 1 minus 6 equal to minus 5 kilometer. What about my velocity? Velocity is given by 2t minus 6. So at t equal to 1, it will be minus 4 kilometer per hour. What about t is equal to 2 hours? T is equal to 2 hours. My S will be 4 minus 12, which is minus 8 kilometer. What about velocity? Velocity will be 2t, means 4 minus 6, and this will be equal to minus 2 kilometer per hour. That means minus means my car is moving minus x direction. This is my minus x and this is my plus x. What about t is equal to 3 hours? My displacement will be 9 minus 18, which is nothing but minus 9 kilometer. That means my car is minus 9, means in negative x direction at 9 kilometer displacement. What about my velocity? Velocity will be 6 minus 6 equal to 0, and that is what we expected, because we know at t is equal to 3 hours my velocity is 0. Till now what we see that my car is moving negative direction, right? Minus 4, this is minus 4, and minus 2 and 0. So my car was moving in minus x direction, where my displacement, for example, here minus 5, if I take minus 8 and then minus 9. So my car was moving in this direction, and after 3 hours at this position my car is stopped, okay, because my velocity is 0 and displacement is minus 9 kilometer. Now what will happen after 3 hours? Let's take t is equal to 4 hours. My displacement is 16 minus 24. 16 minus 24, it become minus 8 kilometer. What I see now, my car is coming back towards my origin. What about velocity? Velocity is 8 minus 6, which is 2 kilometer per hour. If I want to know when the displacement is 0, means when my car is back to origin, because now my car is moving in this direction after 3 hours. So when my car will be at my original point. To find out that, you can do directly from your displacement equation t square minus 6t, s equal to 0, that means t minus 6 equal to 0. This will give you two values of t. One is 0 hours, another is 6 hours. So in the starting of that motion at t is equal to 0 hours, my car was at origin point, and after 6 hours again it will pass through my origin point, right? So here the displacement at 6 hours is your 0. What about velocity at t is equal to 6 hours? So here at t is equal to 6 hours, my displacement is 0. What about my velocity? Velocity is 6 into 2, 12 minus 6. 12 minus 6. So it is 6 kilometer per hour. So when my car was passing through this origin point, it will be having plus 6 kilometer per hour speed or velocity in positive x direction. So now you understood the motion of this car. Car started in negative x direction with reducing speed. You see, initially it was minus 4 means 4 kilometer per hour in negative direction. It become minus 2 means 2 kilometer per hour in negative direction and becomes 0. Right? So this speed or velocity in minus x direction keep on reducing. That is because of my acceleration. My acceleration A is 2 kilometer per hour in positive direction. This is plus 2. So my car is having acceleration in positive x direction, which is 2 kilometer per hour square. So the car was moving in negative direction with reducing speed, because my velocity was in this direction and the acceleration was in this direction, which are opposite to each other. When acceleration is opposite to direction of motion, the speed or velocity of motion will reduce, and that is what happening in this case. Because of this, my car is stopped after completing 9 kilometer in negative x direction, and then because of this acceleration it start moving back to plus x direction, and now it will continue to increase its speed because of acceleration. Now direction of motion of the car and the direction of acceleration in the same direction. That means car will keep on moving in positive x direction with increasing speed, right? So what is the conclusion of this? After 3 hours, my car will continuously move in positive x direction with increasing speed. It will pass through my origin point with the velocity 6 km per hour in positive x direction. So this is the way you can use your displacement time relationship to find out the position of your object at different instant of time. You can find out the velocity, instantaneous velocity at different instant of time, and you can find out the acceleration. In this particular case, the acceleration is constant, and that is equal to 2 km per hour square. But you can have this acceleration may be function of time like 2t minus 2 or something, which gives you the variable acceleration with time. Okay. Now it is a time for 3 conceptual questions. Try these questions and put your comments in comments box. I hope you would have enjoyed this session. If you think you have learned something new today, then please click like button and subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.